Hi, I'm Steve, or Štěpán, if you can pronounce it. I work at Google, and up until recently, I was the tech lead of a project called Canary Analysis Service. This talk is based on a lot of lessons we've learned from canarying not only large populations, but also populations of 3 replicas and even smaller. So first things first, what is canarying? As you might have heard from Rita in a previous talk, canarying comes from the phrase canary in a coal mine, when a long, long time ago, a physician named John Scott Haldane has recommended that we use canaries, the birds in coal mines, to detect dangerous gases. And the idea is that a canary is really small. It has very low volume of blood. It breathes really fast, and so it gets more quickly intoxicated by whatever the dangerous gases might be in a coal mine. Comparatively, a human is large and breathes more slowly, and so the human can see the canary pine for the fjords and can run away. This idea was actually used in British coal mines, according to Wikipedia, the most reliable source, until 1980s. So since we're using this idea, let's take it and abstract it away. We have something large, which we don't want to lose. And we have something small, which we are more OK losing, sadly. And the small thing is here that to detect danger, we are going into something unknown, and so we can use the small thing to detect whether this unknown is or is not dangerous. And so let's put it back into SRE context. We have a large service, something that we need running, and we need to uphold its reliability properties. And we are OK losing a small chunk of it, a limited, bounded chunk of it. And so we deploy a production change with unknown impact. We don't know if the binary is good. We don't know if the configuration is good to that small chunk, and we detect danger. So quick show of hands, who of you is doing canarying process deliberately in your company? About 2/3 of the room. And can you raise your hands if you're doing it automatically as opposed to humans eyeballing graphs? About 1/3-ish of the room. Cool. I'm just going to be checking time every now and then. OK. What we're going to be talking about here is canarying as an A/B test of production systems, specifically automated A/B test. In other words, everything I'm going to be describing here shouldn't require human eyeballs and human brains to actually make decisions. Now, you might still do it that way, but you don't need to. I'm going to be talking about a lot of illustrative examples. They really are illustrations, but my hope is that they will get the point across. In fact, as I was writing the presentation, I've realized that in my examples, I don't think I have more than 10 replicas of anything. So canarying large populations might be a bit of a lie. But then again, what works for small might work for large. And last but not least, simple rules of thumb to get to canarying quickly, to make it easy and approachable and start using it really fast. What we're not going to be talking about is any particular technology, because your organization and your stack might dictate this more than anything. You might be using Prometheus or Stackdriver or whatever else for your monitoring, and your technological choices might actually differ based on that. I'm also not going to be talking about statistics, because in this audience, there's more knowledge of that there than here. And so it would be all a lie. So no real statistics, no real accurate numbers, no real accurate math. Everything is just an illustration. And I'm not going to be covering all there is to it for canarying. There's a lot more than you can squeeze into a 45-minute talk. And so the reality of life is time is limited. Without further ado, to canarying. Canarying has one big problem. It has conflicting incentives. You want to roll out really fast because you want to have fast development cycles, quickly iterate on your new versions, make sure that you learn about the failures quickly so you can go and fix it, ideally the same day, ideally the same hour. But you also want a slow rollout, because you want to have more data to inform your canary process. You want to make sure that your canary process isn't impacted by some temporary random thing that just sometimes happen, the random solar flare. You want a really large canary population, because you want to have really statistically significant data. You want to make sure you're not influenced by an outlier, but by the same token, you want a small population, so that if the canary catches fire and explodes, you don't lose that much of your service. Users don't really notice, by and large. You don't lose your SLO for the rest of the quarter. And you want to select all the metrics, because there are so many potential failure modes in your complex systems, right? This can break, and that can break, and we have metrics for all of these things. It's amazing. But hang on a minute. If each of those metrics can sometimes have a benign failure, canarying on all of them means that you pretty much always have a benign failure. So to make this slightly more complicated, some metrics fundamentally, like inherently to their principle, require more replicas or more time. So you can think of it as a triangle of canarying priorities. You want fast rollout or short canary, you want small impact of a bad canary, and you want a large metric coverage. This is not quite choose-to situation. You need to balance these three goals. You want a fast rollout, you might have to compromise on the metric coverage or compromise on the small blast radius. You want small impact of a bad canary, you might need to compromise, and so on and so forth. If you ignore these, you are risking flaky canarying where you need to make deeper human decisions than something that is easily automated. As with all rules of thumb, this is not universal truth. This is something to get you started. However, it is not something that to treat as universal truth. And more importantly, this is not binary. It is not an either-or. Either you have fast rollout, or you have this or that. This is a spectrum, and so think of it that way. You might be able to go from 5-minute canary to 10-minute canary and gain some extra coverage. So don't see this as an either-or. And so now I'm going to go through, if I remember correctly, 6 examples of various canarying situations. They might seem obvious on these slides, but these are actually coming from real examples and real experience. It is easy to think of them as obvious when they are isolated and available on slides, but being able to see that situation in the real world and connect it to such an example or other examples not on this slide deck is the really key part. So, canarying, A/B testing. You really want to compare apples to apples, except one of those apples has a new binary. So we have our beautiful blue planet. And on this beautiful blue planet, we have 3 front ends deployed in US West, US East, and Europe. And we have a database that is somewhere in North Mexico, I suppose. This is obviously a made-up service. No data center is this big. And so you have about 20 milliseconds from the front end to database in North America, and about 120 milliseconds from Europe to North America. You choose randomly, Europe is the canary, the two data centers in US are the control, and you get a graph that looks like this. Oh no, the latency is terrible. Where did we go wrong? So we have seen a 100 millisecond increase in latency for our canary. Depending on how long the rest of the operation takes, it's 20 milliseconds to the database, maybe this is actually a crushing difference for your service. But hang on a minute. Our observation is that the new release and also different continents have a significant slowdown. So it's important to remember, what is it we wanted to measure? Right? What are the differences between the populations that you might not have really consciously realized when doing this measurement? Another example is a specifically provisioned canary cluster that kind of looks like the production cluster, but it's not really. Like, it might have different architecture or different number of machines or what have you. Or it might get traffic mix only from a certain region. So compare apples to apples. And be mindful that it's very easy to pick up additional things that are not immediately obvious. The continent is really clear. The less clear examples might be different machines, different kernel versions, different versions of your serving stack, or dependencies of your serving stack that get called. Someone else is canarying in the same region as you, their new binary, and the problem is on their side. In this case, a better solution might be to compare within a single continent. So take a chunk of Europe, compare it to the remainder of Europe, and see how they fare. Or possibly do this in each continent so that you are not limited to only a single traffic mix. Maybe the work done in Europe is very different from the work done in the US. Next, what if you have high variance behavior? So let's think latency place. In this graph, you see about 10 replicas-ish of some serving process. And latency is kind of all over the place. Intentionally, there are no numbers, but you can see that it's not exactly the same line. Different replicas have slightly different latency. Some might call it a normal distribution. If you draw it in presentation, it kind of looks like that. Maybe, sorta, maybe not. I don't quite know. But it's a pretty bell curve. And so, OK, this is a fairly typical setup. You will get that often. Maybe the lines will not be so straight over 24 hours, but hey, this is an illustration. So let's choose a canary. And we choose the first two tasks, because they were first two. And we look at it, and oh no, the latency. It's horrible. Look at how bad my canary is. My release is clearly bad. Time to roll back. Well, where did we go wrong? Canary selection process, the way you choose your canary population, is extremely impactful. One example already was the continent. But even within this continent, you have a huge variance in practical deployments, right? So the process of selecting the canary can trigger false positives or false negatives very easily. And you need to be mindful of this. So one way to look at this, and going back to like statistics, is what is the probability that you will select an outlier population? And so think of that as you're choosing both the process that you use to select the canary population, as well as its size. It would not have likely happened if you have randomly chosen, any 10, if you have chosen 5 of those as your canary, so you would have a 50% canary size, although there are downsides to this too. And of course, even then, you cannot fully eliminate that risk. And the selection process doesn't need to be random to cause problems. It just needs to be arbitrary or unaware of this risk. So as an example, imagine those tasks were numbered from 0 to 10, and you just went in order. And it just so happens that 0 and 1 are the top 2. So this means that it doesn't have to be a problem of random process to cause this issue. However, a random process for selecting your canary population nicely illustrates it. Again, going back to the graph, try randomly selecting two replicas many times and see how many times they are going to be clearly skewed, let's say, comparing the mean of the canary and the remaining population. Before and after information can help. We have clearly seen that the same replicas were performing about the same way before and after. But there are issues with this, and we are going to be talking about that a little bit later. Another issue is, well, normal distribution is something we can deal with. What if we have bimodal distribution or multimodal distribution? Maybe we have 2 different machine platforms. Maybe 3, maybe 4, maybe different versions of whatever stack we have. And then it looks like this. Great, I have chosen half of my canary, and it might be, the top half-ish of the graph. To make matters even worse, 2 metrics can have different outliers. In these 2 graphs, we have latency and errors. In case of latency, we have chosen the first 2 tasks, and those were the outliers. But for errors, they were not really. They were kind of somewhere in the pack. OK, so I really don't want this. I want something that's really in the middle of the pack for latency. Great. I have chosen my new canary, and now I have errors outliers. Now, some might say that there is some interesting correlation between errors and latency. Usually, like you might have a misbehaving service of sorts that might exhibit both. But consider if you're looking at more and more metrics in your system. This becomes an optimization problem that's actually not necessarily possible to solve. So the input data can be almost any distribution across your replicas. If you have multimodal data distributions, clustering methods can help you. There has been an interesting talk by Twitter on their Canary analysis system, and they have employed some of those. The metric distribution depends both on population and metric. And what that means is not only does it depend on, am I looking at crashes? Am I looking at RPC latency? but and those might depend on how fast you can process things. But crashes, well, if you have a seg fault, you have a seg fault no matter if you're running it on the most recent Intel or a 386. So it means that there are various dependencies, various functional dependencies between the observed metric behavior and how you're actually doing. And any metric can follow any distribution, and pairwise, any two metrics can follow different distributions with different spread of the good or bad tasks. So unless you have specific prior knowledge, you might have to, for example, drop some metrics that you realize are not useful because you have possibly covered that failure mode by some other metrics. This decision might have to be done at runtime if necessary, depending on how much you actually canary. OK. So now let's look at canary duration. The more time we have, the better, right? So this is an example service with cache. This cache is in memory, and if there's a cache miss, then it reads from some expensive high latency storage, reads it into cache, and then from that on, it will respond from memory again, and everything is great. So you have the cache responding at wonderful latency, then you restart it, and you are having cache misses left and right for a while, for some number of hours. And then slowly over time, the cache warms up, and you're back in steady state serving mode. OK, how does that fit into our canarying? Well, I canary for an hour. I look at the latency, and I go, no! Oh, dear, look at that latency. It's so high. It's like at least 50 furlongs higher than the other one. And so this is a problem, right? So how do we solve this? Well, one option is to restart the control. Because then I'm comparing apples to apples, right? I'm looking at, let's say, 1 hour of the cache running completely cold, both in the canary and in the control. That's totally apples to apples, right? And it's true. So you do that, you restart both, and they look kind of like this. You look at the first hour, and it looks perfect, right? Like it matches exactly as the cache keeps warming up. But unfortunately, if you look at that, you might quickly realize that the graph changes after a while. And later on, it actually looks terrible again. Because you were comparing apples to apples, but you are not actually comparing the things that you want. You are trying to decide the fate of apples by looking at something totally unrelated, and then go, oh yeah, apples are fine. You are comparing the post-startup behavior, the least relevant part of the behavior of your system, and trying to decide whether the system in steady state is going to be healthy. And that is a problem, right? Now, the downside is you might need more time. You might need to find the point of stable operation and start canarying from there, so that you can easily see that this is a regression, but you do need to wait possibly several hours, several days, several minutes, depending on the nature of your cache, until you reach what you consider steady state. Worse yet, you go to a new platform, you double the amount of memory, now your steady state is pushed back, and you need to make sure this is reflected appropriately in your canary process. All right, so we need to connect what we're judging to what we actually meant to decide. We canary to make a decision about the fate of the production change, and this is really important. So another thing is memory leak. I'm not going to ask you to raise your hand if you've ever dealt with memory leak. And some still do. Thank you. I'm not alone. So this is an idealized memory leak, right? Your memory starts somewhere here after you started, and it goes up over time, and then you hit a limit, an explosion, and you need to restart or do some sort of mitigation, automated or manual or whatever. So this is the ideal way. Now, of course, reality is a bit annoying. In reality, it looks like this. It's a squiggly line of allocations and deallocations and garbage collections and memory returned to the machine. And you're looking at that and you're trying to decide, is this OK? Yeah? If you didn't see the previous picture, would you have said it was OK? Actually, quick show of hands, would you have? OK, about 50% of the room. I like that. Yes, it is basically a coin flip. So detecting memory leaks with canarying may require way longer canarying and pushes us away from the fast rollout, short canary kind of part of the triangle. Not all memory-based tests require long canary. Again, going back to this example, what if we had a replica that was steady state, and then the canary had like twice as much memory usage? That is something you can decide fast. But if you're trying to decide something as nuanced as a slow memory leak, then you might need more time. Moreover, it's easy to think that canarying and monitoring should be the same. And this is a significant risk in both directions. Canarying cannot ever obviate monitoring, because canarying is a time-limited process. Because canarying is here for making the decision, at some point in time, you have made this decision. You have made the decision to release the binary, to roll it out, to push the config. And at that point, canarying is over. Unless this is also the point when you're doing a new release, then you are spending most of your time not canarying. And this is why monitoring is key. And you might be monitoring for very different things. You might be monitoring that you are getting close to your memory limit. Conversely, it is tempting to say, oh yeah, I know what I'll do. I'll use the things that I use for monitoring for canarying. This works a little bit better, and I will touch on that later. But canarying is also different in that canarying is kind of by definition looking at a subset of your system. So if you can make decisions about all your replicas, that doesn't necessarily mean you can make a decision about a subset of replicas. And my favorite example for this is master elected jobs, where there can only be one. It's much like Highlander. And you cannot really consider any subset of that population. So bear in mind that these are related but not directly connected concepts. Speaking of how to work around that, before and after canarying. So maybe I can just be focused on deploying quickly and having ability to roll back quickly as well if I notice problems. So maybe I can use the entire service as my canary and just go back real fast. So let's say you can go back so fast that even a catastrophic canary will actually not impact your quarterly SLO unrecoverably. First off, I'm really jealous. But let's explore that. So this is a 24-hour cycle of something. I have chosen latency just because it's a convenient proxy for, let's say, the daily cycle. You have more load, you might have higher latency. And this is not unusual for a service that we might be running. We might be running multiple services on multiple locations, but this is a reasonable illustration of what we see. All right. Now, oh gee, I wish the table was flat. Now, this might be a bit of an extreme example, but let's say we have, Canary is from 9 a.m. to whatever, maybe like 1 p.m., and control is from midnight to 6. So we are doing a before and after Canary. Great. So what we have learned is that the Canary looks really terrible, because the latency is twice as bad. Right? You look at this graph, and you see you can't reach any other conclusion. This is the metric. This is the result of the metric at this time and that time. And, well, it's twice as bad. Not really what you meant to do, is it? And so we are comparing apples to stale apples. This is what it looked like way back when it was fresh, but now is no longer relevant. Global comparison also doesn't solve this necessarily. You might smooth out the day cycle to a degree, but A, not completely, And so do you understand to what degree you haven't? And you might have different usage patterns in different regions. So now you might be mixing apples, pears, stale pears, and so on through all the kinds of fruit you have deployed in various regions. Now, this example is kind of exaggerated. If you believe that your canary has twice the latency and you are able to roll back quickly, you probably would if you didn't realize the daily cycle to this. But it's an illustration because there are other things at smaller time scale that can also impact you. For example, traffic spikes during big events like, I don't know, Super Bowl, elections, whatever is a thing in the region where you are deployed might impact you. Machine deaths, network cuts, and network events in general. So this is not always the wrong choice, but be very cautious. First off, be very confident that you can detect issues if you effectively roll out from 0 to 100% in a single step. That is inherently something that might not jive well with many of our typical practices. Be very confident you can roll back fast, but you also lose, potentially, some of the data fidelity you are hoping for. In a sense, time is a really big change. And if we are trying to minimize the difference between our two populations to be only the thing we are deciding about, then adding time to the mix can be dangerous and extremely unpredictable. All right. So now I have this complicated system. And I want to make sure that this complicated system keeps running. And it has all sorts of complicated features. And they should all be running, because otherwise people will be writing on Twitter, oh, gee, they are muppets. They don't know how to run this thing. And so I want to test for all this so that every new release still has all these features working. So I'll add more tests. OK, so imagine 1 in 100 of your tests fails. It may fail for legitimate reasons, or it might be false positive because something went wrong in your testing process. As we have discussed until now, that can happen. And so if a metric fails the canary test, a human needs to go and look. OK, so probability of a single test failure is 1%. Now, I have 100 features that I care about. So as it turns out, and don't look at the math too much, if you have 100 tests that you require in Canarying, and on average 1% of them fails, you have 2/3 of a chance that you will be inspecting your release. So 2 out of 3 releases will need human eyeballs and human decision. I believe the term frequently used is toil, because this basically is, you're not canarying anymore. You're not doing automated canarying. You are doing graph subselection. And that's different. You're doing automatic triage. And so this was a lie, obviously, right? You might have many correlated failures. Your latency for feature 1 and 2 and 3 and 75 might be correlated together. So it's not like those failures are necessarily independent. But it's a useful lie. One of my favorite quotes is by George Box, a statistician, who said all models are wrong, but some are useful. And this model is useful in showing you that these problems in your system, these problems in your system can give you a lot of manual toil and remove the benefit of the canarying. Making things worse, imagine you are pitching automated canarying to your development partners, right? To the people developing the product. What will they say if they go, oh yeah, and by the way, you need to look at 2 out of 3 releases you do? That is going to be a very difficult pitch. So you are probably going to be able to go better than 1% if you added more data. More replicas in the canary population, more time, what have you. We have discussed these concepts before. But again, remember the triangle. Remember that if you want more coverage, you might need to compromise on some of the other aspects. You might think, OK, so I will just fail it if 10% checks fail. And only then will I bring a human. But this is a problematic proposal, because why 10? Why not 5? Why not 20? Where did this number come from? can you please connect this number to an actual business need or any kind of failure analysis? Another problem with this is that the checks that people will think of are not always of equal importance. So is it the same importance that we go from making money to not making money, and that we have increased latency a little bit? Maybe not. Maybe we want to make sure that if we stop making money, that check will cause a human to look at things, even if it didn't trigger the 10% threshold. So now you have some sort of weights or a whitelist or something increasingly complicated and kind of organic and homegrown, your free-range canaries. It becomes very complex. So unless you are principled about keeping this narrow, you might get to a system where you don't have your canary setup anchored in any kind of business goals, nor in any kind of sound statistics, which, as I mentioned, I'm not going to be going through. So the way out, prefer few metrics. Can you please raise your hand if you will be able to name 3 metrics that most clearly indicate whether your system is fine? Maybe 10% of the room? OK. So if you have not attended one of the SLI workshops, I'm not sure if there are any left, but it's definitely something to think about. Because Oh, excellent. The talk right after mine is about SLIs, Liz tells me. So connecting your Canarying to your SLIs is really useful, because your SLIs ideally should be connected to your business needs, and so by proxy, you connect your release process to that as well. It doesn't mean you need 3 metrics or any particular magic number. I've literally just made it up. But it does mean the inverse. You can cover a lot of failure modes with just a handful of metrics. And so as long as these metrics are reasonably representative of your service level, which they should be because it's in the name, then you can cover a huge amount of failure modes with very simple canarying setup. And going back to the goal of my talk, simple and approachable canarying is part of what I'm trying to pitch here. So canarying in these 3 simple steps. Choose only a few good metrics. They need to represent the measure of problems in your service. Go one direction if your service is broken. Go the other direction if it's doing better. They should be connected to your SLIs. They don't have to, but it helps. And it's a very good idea to have at least one of them connected directly to your SLI. Make sure your canary and control population is correctly representative. This is really easy to get wrong. I can tell from experience, people get it wrong all the time. We do hundreds of thousands of evaluations a day, and people get it wrong all the time. This is by far the easiest to miss out on, because it is extremely contextual. Random process, when not well controlled, can also bring out a lot of interesting false positives. And for that matter, have a false positive rate in mind and measure this. Make sure you know what level of human interaction are you OK with. And last but not least, compare apples to apples, but keep in mind what you're trying to decide on. Don't compare apples to stale apples. Make sure that you are comparing populations that are representative of the decision that you're trying to make. Because again, canarying is a decision process. It is something that will help you decide whether to go forward or not. And maybe there's another one. So hang on a minute. This doesn't catch what I need. I have a really complex system. What do I do next? Those 3 simple steps are BS. A relatively simple trick to that is multi-stage canarying, where you start your canary short and simple. Because going back to the triangle, you want to make sure that you have fast iteration and you have small population and all that good stuff. So you have a small canary that tests for the key things. Are you dramatically exploding? Are you making no money? Are you currently on fire? Are your SLIs looking sad? And if that passes, you can take the next step, where you might have more metrics that, however, require more data and more time to be actually properly useful for making an informed decision. So you can do that later. You have already established that your canary is this tall, but in fact, your canary must be distal to take the ride. And so you make sure that you have 2 stages that filter this. So canarying can be easy and approachable. Just follow these 3.5 steps, and then iterate and make sure you choose what works best for you. Because at the end of the day, you know your systems the best, you know your infrastructure the best, and what works in your context might not work in somebody else's. Think of the triangle of canarying priorities. It will help you choose the trade-offs and make the trade-offs more explicit so you can make them deliberately rather than accidentally. It's useful to have some statistical foundations. It's not necessary to have PhD in statistics. And some of these questions can be automated away with sufficiently advanced software. I've mentioned I was working on Canary analysis service. We have published a paper in ACMQ about that, but there are other systems like this out there, and so definitely take a chance and study them. And with that, I believe we have time for questions. OK, 5 minutes.
What do you consider an acceptable false positive rate for canary failure?
I think it depends on your organization, on your release rate, on what happens after that. So I'm not comfortable giving you a number, because I think that number that might work for me might not work for many people in this audience. I think it would be a lie. The lower, the better, though.
Hi. So which method do you use to recognize false positive? So when you do a rollback and you shouldn't have?
So in practice, what we've done with canary analysis is humans. It's extremely subjective. Both alerting and canarying are extremely subjective situations, in that frequently it is up to the recipient to decide whether this is good or bad, expected or not. It's very difficult to do this automatically, especially when you consider that frequently you might have deliberate changes. You might be OK doubling the latency, because now you have this extra bucket of features. So this also goes to the previous question, what is the rate of false positives? These things are not easy to predict. So they might trip up the automated systems that try to enforce previously encoded behavior. But is it a false positive? Maybe. So ultimately, finding things that shouldn't have happened is done through humans. And in practice, we have found that it's fairly polarized. Frequently, false positives are easy to find because someone was failing 50% of their releases. It is extremely obvious that they did not actually have 50% of bad releases. They were actually doing pretty well. And on the flip side, many teams would not have any flagged bad releases at all, or maybe 1 or 2 every 100, 200 releases that were genuinely bugs. So hopefully that's a good answer.
One more. All right.
Steve, does using Canary remove the need for additional environments, or do you still have like development, integration, pre-production, production?
As with all hard questions, the answer is maybe. Because this solves a problem, it solves a need. However, those environments might be required for other needs. You might want to have a totally independently deployed sandbox for developers to play around, but it has no connection to production, as an example of a separate environment. I personally prefer to especially not have a dedicated canarying environment, because it is difficult to make it look exactly like production, and so it increases the risk of having some unsuspecting differences between the two environments that sway you either towards passing a bad canary or failing a good canary. But I wouldn't say it obviates the need, no. And with that, I believe we're out of time.
That's it. Thank you very much.
Thank you.